So good morning, guys. Today we're going to talk about limits of rational functions. And later on, we'll discuss how to solve, how to evaluate. So what we're going to do as of this moment is I'm going to make an analogy on what is a limit of a function. Suppose you are watching TV and unfortunately, you get a massive craving of pizza. So what do? You get up from your couch and you go to a location where the pizza is. But the good thing here is that you have a leftover pizza in your kitchen. So you walk closer and closer, getting to your kitchen to get the pizza. If someone would describe what you are doing, it's actually you are going to a direction. In this case, it's where the location of the pizza, right? In the same manner, in evaluating limits of function, guys, we want to do the same thing. We're looking for where the function is going to, or technically, the direction of the function. Let me share you my screen and how to solve for some of the limit of the function. Just give me a minute and a window and share my here. So let's start first with the first example. We have limits of x squared minus x minus 6 over x minus 3 as x approaches to 3. Now, you might be thinking that we can just immediately substitute the value of x equals 3 in this case. Unfortunately, we can't because that would give us a 0 denominator. Remember, we can't allow that to happen. By the way, this is an example of rational function. Remember that rational functions are of the form f of x over q of x, where q of x should never be equal to 0. Okay, because if it will be 0, it will be undefined. So how do we go about solving this case here? First is you need to examine the limit function or the function itself. We can see that the numerator can be factored. How? This is how we do it. Take a look at the factor of negative 6. And when you look for the factors of negative 6, make sure that the sum of those factors should be found in the middle term. In this case, it's negative 1. So the factors that we can think of are negative 3 and 2. Because when we multiply these two numbers, you would get negative 6. And when we add them, this would give us negative 1, which is technically in the middle term. The factor then would be x minus 3 times x plus 2. Okay? Now, we would be able to rewrite the limit of the function, guys, but this time, we're going to be using this form here instead of writing this 1. We have x minus 3 times x plus 2 over x minus 3 as x approaches to 3. This form, we can cancel the similar term, which is x minus 3 that is found in the numerator and denominator. What is left is limit of x plus 2 as x approaches to 3 and limit, substituting x as 3, we would have 3 plus 2, x approaches to 3. This would give us limits of 5 as x approaches to 3. We have here 5 because the limit of a constant is a constant itself. Okay? I hope it's clear. Do you guys have question for that example?
None, sir.
Very good. Perfect. Good job. So let's continue with the second example. Let me just grab my paper here and tell or write the second example. The second example is limits of square root of x plus 3 minus 2 over x minus 1 as x approaches to 1. If you notice, guys, the problem here is that we cannot factor the numerator as well as the denominator. It's different scenario. So if you are going to substitute x as 1 here, it would give us a zero denominator, in which, again, we are not allowing that to happen. So how do we go about this, sir? We can apply the rationalizing the numerator here by how? We are going to multiply both the numerator and the denominator by the conjugate of the numerator. How to look for the conjugate of the numerator? This is how you do it. You copy the first term, x plus 3. However, you change the sign that is used in the numerator to its opposite sign. So instead of subtraction, you do addition. And you do it as well as here in the denominator. Okay, now we're going to multiply these two things. We would have limit of x plus 3 minus 2 times this one, square root of x plus 3 plus 2 over x minus 1 times the quantity of x plus 3 plus 2 as x approaches to positive 1. Okay? Now, you notice that this form here, this is somewhat familiar. We can apply the concept of the difference of squares. If we're going to expand this, we would get a minus b times a plus b. This form is similar to this form here, having a as square root of x plus 3 and having b as equal to 2. So we can rewrite the numerator in this form. Limit of the square root of x plus 3 squared minus 2 squared over the quantity x minus 1 times the quantity x plus 3 plus 2 as x approaches to 1. Let's simplify the numerator. So we have limit x plus 3 because you can just cancel out the radical symbol and the exponent 2. What is 2 raised to the power of 2? You just have to evaluate it. You would get 4 and x approaches to 1. You just copy the denominator, which is the product of x minus 1 times square root of x plus 3 plus 2. And you are going to solve them. What is 3 minus 4? 3 minus 4 is just negative 1. So we have this answer here, limit of x minus 1 over x minus 1 times square root of x plus 3 plus 2 as x approaches to 1. In this case, we can now cancel similar term, and that is x minus 1 from the numerator and x minus 1 from the denominator. All right, so this would become limit of 1 over square root of x plus 3 plus 2 as x approaches to 1. Now, let's try to test or evaluate if we would get a 0 in the denominator by substituting x equals 1. Let's do it mentally. So if x is equal to 1, that's going to be 1 plus 3, right? Which is equal to 4. And what is the square root of 4? That's 2. And 2 plus 2, it's 4. So it's not 0. In other words, it is safe for us to continue in doing the process, substituting x as equal to 1. So let's do that. Limits of 1 over square root of 1 plus 3 plus 2 as x approaches to 1, we would get limits of x approaches to 1 over 4, right? And what is the limit of a constant? That's equal to the constant itself. So it's 1/4. In other words, the answer for this example here, this one, the limit of square root of x plus 3 minus 2 over x minus 1 as x approaches to 1, the answer is 1/4. Do you have questions, guys?
None, sir.
It's easy, right? So far, it's easy.
Yes, sir. So
Yes,
far,
sir.
sir.
Good. So I want you to do an example, guys, or examples that you can process or solve on your own. You can grab a sheet of paper try to evaluate the limit of this function 3 plus h squared minus 9 over h as h approaches to 0. The second one, limit of square root of t squared plus 9 minus 3 over t squared as t approaches to 0. So yeah, I'll give you maybe 3 minutes to 4 minutes to answer these two items, and I'll get back to you. Okay? It's already what 8:05 a.m. So maybe 8:10. You guys are done?
Yes, sir.
Yes, sir.
All right.
Done,
So
sir.
Yes,
just
sir.
try to like say the summary of how did you solve item number one. Anyone can share their answers.
Me, sir? Is it?
Go
Okay, sir.
Pat.
Okay,
Go.
first, sir, we expand 3 plus h squared. And after that, we have 9 plus 6h plus h squared minus 9. So we cancel 9 over h. We cancel 9. We are left with h squared plus 6h over h. Then we can cancel h by using the common, what was that? But I
Common
forgot the
factor.
terms. Yeah, that one, sir. So we can cancel h in the denominator and the numerator, then we are left with h plus 6. Then substitute the h to 0. So substitute h to 0 plus 6 is equals to h, sir. So the limit of 6 is from h is equals to h to 0 is equals to 6.
Very good. So the limit of the function as h approaches to 0, the answer is 6. Very good. So what we did here, guys, is just expanding this binomial term and then canceling out 9 because 9 minus 9 is 0. What is left is this one here, 6h plus h squared. Factoring the common term from the numerator, which is h, we would get h times 6 plus h, or the quantity x plus h. And then we can cancel the h from the numerator and the denominator. So it would give us 6 plus h, and then substituting h as 0, you would get 6 as the limit of this function. How about the second item? What's your answer? Did you get 1/4 or 1 over 6?
1 over
1
6,
over
1
sir.
over
6, sir.
6, right? So what we did here, we or you rationalize the numerator. You follow this same process here, right? Agree? So,
Agree, sir.
Yes, sir.
yes, you multiply it with its conjugate. I mean, you multiply the numerator and denominator by the conjugate of the numerator. We have t squared plus 9 minus 3 over t squared times t squared plus 9 plus 3 over t squared plus 9 plus 3. If we're going to continue the same process as we did to this example that we have here, this one here, you would get the answer that 1 over 6. And I believe every one of you got it right. So, now in summary, guys, when you evaluate limit of the function, you need to consider first the denominator. So you need to test maybe if the denominator would become 0 if you are going to substitute the value of x, or where the x is going to, or where it's approaching to. If it's 0, you would have to do either factor if it's possible, simplify the function if it's possible, or rationalize it. Now, sir, if the denominator would not become 0, what will happen? You are safe to continue with the process. So just simplify it, and once you get to the limit of the constant itself is the answer. Clear? Now, sir, what if after we simplify, or after we factor, after we rationalize, after we expand, sir, we still get a 0 denominator? What we are going to do for that, sir? It's another scenario, by the way, guys, and I'll discuss it next meeting. It's part of infinite limits, but this time we're going to be focusing on those rational functions where the limit exists. Okay? Now, as part of your test, I hope you can answer my exam or my assignment. Let's say if you can. So this is gonna be the examination, guys. I mean, part of the quiz. I mean, not technically the same, but it's similar to this. If you would be able to cover this. The difference for item number 2, which is part of A, guys, it's actually this time the thing that you're going to rationalize is a denominator. If you're going to test it, substituting 5 as your t here, you would get 5 minus 1, right? And what is the square root of 4? 2. You would have 2 minus 2, so it's going to be 0. And we can't do that. We are going to rationalize the denominator by multiplying both the numerator and the denominator by the conjugate of the denominator. And then this one here, I hope you would be able to explain why is it that f of 1 is not equal to the limit of the function when x is approaching to 1. You might want to try to revisit your concepts of evaluating function during your general mathematics or your lower level math. Those topics would help you out. Okay, so I hope that's going to cover the test. You see there. Do you have any questions before we end this session, guys? I encourage you to ask questions though if you have any. None so far?
Yeah, none, sir.
Yes, Eli.
Sir, do we have to put the limits in the final answer, sir?
That's a good question. That's a good question. Whenever you solve limit, guys, every time you write an expression, always include the limit notation. You only stop doing that when you get the constant. For example, this one here. You see that this is already a constant. You finalize your answer with the constant itself. Okay? But before that, or the solutions prior to that, you notice here, we always include the limit. So limit, guys, is part of it. And just a hint, the second question for letter B here, why it's equal or why it's not equal to, I mean, f of 1 is not equal to the limit. It's because, again, the limit is concerned about the direction of the function, not the actual value of the function. Okay? No more questions?
None, sir.
Great. How about the
None,
others?
sir.
Thank you so much. And thank you so much for listening, guys. And see you next time.
Thank you, sir.
Thank you,
Bye,
sir.
sir.
Thank
Thank you,
you.
sir.